So this is the second video in this module, and we are building a Simio model of a tandem queuing system. So you can see the information that we have here. We have server 1 and server 2. The in-arrival time and service times are given. The metrics that we're interested in are time in system, number in system, and throughput, all at steady state. And we have some standard queuing assumptions. Servers have capacity 1, FIFO queues, initially infinite capacity queues. In this video, what we're going to do is look at the experimentation component, and in particular experimental responses. So in the first video, we built this basic model, and so we can run the model, and we had a 240-hour runtime that we set, and if we then fast forward, we can look at the results of that run. So down here you can see that we've run 240 hours, and then we can go and look at the queuing results, which we had filtered in the previous video. Now, of course, what we see when we look at these results is just the replication one. So these are the statistics we get from running a single replication. And as we know, because we have random arrivals and processing, we need to replicate the model so that we can get statistically valid results. And so in Simio, the way to do that is by creating an experiment. So I'm going to go back to the project home and just simply click on the new experiment button, and you can see that Simio creates a default experiment which has 10 replications. And so if I just click run here, we can see that it's going to run the default 10 replications. Each replication is going to run for 240 hours. And if you look down here, you can see that the replications are actually not run in order. That's because Simio will run the replication simultaneously depending on how many cores your processor has. So if you have a quad core processor, it's going to run 4 replications simultaneously, and they won't always finish in numerical order. So our replications have run. We can then look at the pivot grid, and we can see now we have these additional columns relative to what we saw when we ran in interactive mode. In interactive mode, we had a single observation, and now we have statistics across 10 replications. So I have the average value of, in this case, right here, the average number of entities in the system over our 10 replications. And so we have the minimum and the maximum and the half width of the 95% confidence interval on the mean. And so we can filter this the same way, the pivot grid, the same way that we did in the interactive run. So let's go ahead and do that. So we are interested, as I said, in number in system, time in system. So I'll just filter that down, and then I will filter the averages. And now we can see the statistics that we're primarily interested in. Now, one thing that we haven't discussed yet is that we are interested in the values at steady state. And we know, because we have a queuing system where the first entities arrive when the system is empty and idle, that the system will go through a transient phase. And if you're not familiar with that, there's a video module on the initial transient period, and you should definitely watch that. And the method that we use to get to steady state is by using what's called a warm-up period. So over here on the right, I'm just going to set this value to 50 hours for our warm-up. And so now what happens is Simio will run 240 hours, each replication that is, and after 50 hours, the system state will be maintained, but all of the statistics will be cleared. So hopefully when you reach 50 hours, the system has reached steady state, and so we will simply start keeping statistics from that point in time. And so now when we run, we are actually running each replication for 240 hours, but we only have 190 hours of statistics that are being collected. And so we're going to let that run, and then we will have a look at the results. So as I said before, when we go to the pivot grid, our filtering remains, and you can see these values have changed somewhat from the previous values where we don't have a warm-up. So again, the transient period, there's a video module on the transient period, and you should definitely have a look at that. But in general, we set a warm-up period to make sure that we get out of the transient phase before we start collecting statistics, if what we're after are steady state results. Next, we will define experimental responses for our two performance metrics of interest. Again, we're also interested in the throughput, and we will get to that in just a minute. So I'm going to click on the Add Response button, and you can see that Simio creates an experimental response. And we're going to go to the properties, and I'm going to change the value. The first one we're going to do is called time and system, or TIS. And so an experimental response is calculated at the end of a replication. So Simio runs the replication, and then at the end calculates the value based on the expression that you're given. So the expression that we need here is default entity population time and system average. That's the Simio expression we need for our response. And let's just take a second to discuss what that means. And so we have an entire video module on Simio expressions, because building Simio expressions is one of the critical skills that you need. But let me just spend a minute talking about that. And so here I've replicated the expression that we used, and this expression has several different components. And so the default entity is an instance of the model object. So if we go back to our Simio model and look at the model itself, that's this value here. So default entity is an instance of the model entity object. Then we have population, and so what this is saying is we want to consider the entire population of run spaces, or sometimes called realizations. So as the model runs, here, let me put it in interactive mode here, we're creating run spaces of the default entity instance, and we're interested in tabulating the statistics over the entire population of run spaces. And because we're calculating this at the end of the run, this will be the entire population of entities that were created during the run. And then what we're interested in is the statistic, the average time in system. And so that's the quick description of that response, or that expression. So let me then go and add our second response. Our second response is going to be number in system. And so this is going to be very similar to the previous one. We're interested still in the default entity population, but this time we're interested in the number in system average. So very similar, except instead of the time in system, we're interested in the number in system. And so at this point, if we run our model, we're going to see that Simio will then report these average values. Oops, I got to reset first, forgot to do that. We'll report the average values in the experiment. So there they are, right there, as it's running. So we've completed 4 of our 10 replications. And when we finish, what we're going to see is that these average values of 17.0152 and 0.353538 are the exact same values that we get in the average column here in our pivot grid. So we've simply defined these as experimental responses so that we can see those in our experiment design. By defining these responses, Simio will also create experiment responses, which we see here on the response tab. And if you click on response pull down, you can switch back and forth between our 2 responses. And what we see is the SMOR plot, or Simio measure of error and risk. And so we have a video, an entire video that talks about SMOR plots, but sort of from an initial quick and dirty standpoint, the SMOR plot gives me a graphical view of some of the important statistics from our run. And so if you just mouse hover over the components, you can see the mean value. Then the beige box here is the confidence interval on the mean. Then the box here gives us the median, the upper percentile, the lower percentile. The ends give me the extreme values. And these light blue boxes give me the confidence interval on, in this case, the lower percentile. There's actually one on the upper percentile too, but we don't have enough replications to actually tabulate or calculate that yet. And so when we hover over, we get the confidence interval on the mean. And so note when we can also get the histogram. So here we have 10 values, 10 replications, and so we can see the individual 10 values the average value for time and system, and we see the same thing for number and system. So let's go back to our model and let's just increase the number of replications to 50 and run, and then let's go watch the s'more plot as we run additional replication. And you can see that as the replications are run, Simio is dynamically updating the s'more plot. And as we would expect happens, the confidence interval on the mean is getting smaller because we're becoming more confident about our estimate. Now we have enough data to calculate the confidence interval on the upper percentile, and then we're seeing the additional replication values show up within our histogram view. Now that our 50 replications have finished, so we go back and look at our design and we see that we have 50 replications run, we can see the shape of the histogram here. And so this histogram is an estimate of the probability distribution for the average, in this case, time and system at steady state. So we can go back to our design here. And the final thing that we want to cover, I'm going to reset this first, is our additional performance metric that we talked about, and that's throughput. What I'd like to know is the throughput of entities through our system. And so we're going to define that. Oops, I didn't mean to add a constraint. Let me add another response, and we're going to call this throughput. And our expression for throughput is as follows. First of all, I need to unfilter the content here that is again discussed in the dedicated module on the expression builder. And we want sync1, sync1, can't type today, sync1 input buffer number entered divided by run time now minus run warm-up period. That's the expression that we want. And before we run, let's go back and have a look at that expression. So this is the expression that we just typed in, sync1.input buffer number entered divided by run time now minus run.warmup period. And so this value, sync1, says the input buffer of the object instance sync1, how many entities entered. Because we define this as an experiment response, it's calculated at the end of a replication. So this will be the total number of entities that entered the sync over the entire run. The run.time now is the current simulation time. So at any time that the simulation is running, run.time now will give you that current runtime. Again, because we're calculating this at the end of the replication, this will be the termination time of the replication. And because we have a warm-up of 50 hours, we need to subtract that off. We need to subtract that from our runtime. So we ran for 240 hours, but at time 50, the value for number entered was reset to 0 because we said we want to start calculating results or tabulating results at the end of the warm-up period. So in order to calculate the throughput or the number of entities per unit time, we have to divide by the time that the actual calculations were done over. And so that's our last response. So let me reset here and let's run the value or run the replication. And while this is running, we would say what we expect this throughput value to be is 48, right? And why would we expect, as it's running, let's discuss this, why would we expect that value to be 48? Well, if we go back to our, let's see here, oops, there we go. We have inner arrival time of 1.25 minutes, and so the arrival rate is simply 1 divided by 1.25 minutes, which equates to exactly 48 entities per hour. So assuming that server 1 and server 2 can keep up with the arrivals, which we know that they can because the service time here and here, the mean service time, are both less than the inner arrival time. Oops, I don't need to go there. Our expectation is that this will be 48. And we see after our 33 runs out of our 50, we're getting something very close to 48. And if we go to our s'more plot, so we can actually observe these values, we can see that we have a fairly tight band between a lower value of a little bit over 47 and a high value of a little bit over 49 that we have from our experimentation, and the expected value here is right at 48, so 48.98, and our confidence interval half width is quite small, also about 0.12. So we're fairly confident at this point about our estimate and our calculation of the model throughput. So that concludes this video on setting up a Simio experiment. Again, what we did was we created the experiment, we then added the warm-up period, and then we defined 3 responses: time in system, number in system, and throughput. And then we looked at the SMORE plot so that we could evaluate the metrics at the end of the run. In the next video, what we're going to look at is looking at adding capacities to the buffers. So our assumptions that we had for the first 2 models was that we have infinite capacity queues. In the next video, we're going to look at adding capacity so that we introduce blocking and starving into the system.